Hello, family. Welcome to another session of Maths Fanatics 24/7. In this video, we're going to be looking at probability, specifically focusing on independent events, mutually exclusive events, and exhaustive and complement events. Perfect. So let's start with the first question here. So firstly, we need to read the instructions, which goes events A, B, and C occur as follows, where A and B are independent events. So by independent, they're basically telling me the formula that for A and B, I can use probability of A and B. Remember, this is the symbol for and. So they are used interchangeably. You can put and like that or that one, doesn't matter. PA multiplied by PB. Always when you hear the word independent, you always write this formula down. Awesome. Okay. And then they gave me probability of A, probability of B, probability of A and B is given. And then probability of C is also given, right? Awesome. And then they say there are 4, 5, 6 people in event A. Okay. So this is the total number of people in event A. Okay, perfect. Now this question says, are event A and B mutually exclusive? They're asking us if they are mutually exclusive. Remember, mutually exclusive formula is this. Probability of A and B must be equals to 0, exactly 0, if they are mutually exclusive. But if I check here, probability of A and B is not equals to 0. Therefore, these events are not going to be mutually exclusive. So your answer will be no, right? Your reason is going to be P, A, and B is equals to 0.1596, which is not equals to 0. Does make sense? Perfect. And then we're fine with that. By using the appropriate formula, show that the probability of A, the U means or. If they use the U, sometimes they'll say or B equals to 0.64. Okay. So obviously, there's only one formula that uses or, the addition rule. That's the only formula that comes to my mind now. PA or B is the same as PA plus PB minus P, A, and B. This is the addition rule. Sharp. PA is that 0.38, right? Plus PB is 0.42. PA and B so we're going to minus 0.1596. Awesome. And then let's see what answer we're going to get on a calculator. So we have 0.38 plus 0.42 minus 0.1596, which gives me, to 2 decimal places, it gives me 0.64, which is proven. Do you see it? Awesome. And then now they want us to calculate the number of people in the sample space. Okay, to find the number of people in the sample space, I'm going to use this part here because they gave me the number of people in event A, and I also know the probability in event A, right? Perfect. So let me just write the formula down. Remember, the formula is this. P of event A is the same as number of people in event A divided by the total number of people in the sample space, which is what we're looking for. Right. So I can always switch these things around. The NS can go there, the PA can come in. So NS will be the same as NA over PA. I'm going to make a video on important algebra techniques that you need to know across mathematics subject, né? And then it should be uploaded soon. You should be looking out for it so that you know these techniques that I just used here, like switching around and all other important types of algebra rules. So in this case, I'm sorted now. I have number of people in A, which is 4, 5, 6. And then I have probability of A, which is 0.38, right? And then let's see what this gives us. So this gives us 4, 5, 6 over 0.38, right? Which is 1,200 people in total. So in total, we have 1,200 people. Okay. Now they want us to determine the number of people that are not in C. Ne? Awesome. So I'll show you something here. This symbol here with a line means not C. Ne? But there's this formula ne? For complements. Ne? Probability of C plus probability of not C will always add up to 1. Okay. Perfect. Probability of C is known, is 0.28. Ne? So which means probability of not C, right, is going to be 1 minus the probability of C, which is 0.28. And then this gives us how much? It should be 0.72, right? Yeah, 0.72. And then from there, I know this, right? I know that PC, P not C, I mean, can be written as N not C divided by N of the sample space. So the number of not C divided by the total gives me probability of not C, which is 0.72, right? Perfect. But now I know that number of sample space is 1,200, right? So I can have this now. 0.72 over 1,200. And then N not C. Obviously, I'm going to cross multiply here. This times 1 just remains that. That times that gives me this, right? And then let's see how much will this be on the calculator. So I already have 1.2 there. I'm just going to times it by 0.72, right? So multiply by 0.72. It gives me 864 people. Right? So it's 864 people. You see. Perfect. And then that's finito about this question. I'm sure it was easy and understandable. Keep on looking for more videos like this. I'll keep on uploading. And please don't forget to share with family and friends. Thank you very much for your time. Till we meet again in another session of Maths Fanatics 24/7. A luta continua. Tango.